So we want to find the water of the crystallization. Okay, that's the next part. So the technician makes 500 cm cube of 0.5 mole per dm cube ethane dioic acid solution by dissolving 31.5 grams of a hydrated. So this is the total hydrated, and this will give us the moles of anhydrous. Like once it is dissolved, it will lose its water of crystallization. So first, using the concentration and the volume, we will find the moles. So if we want the moles here, we have the concentration and the volume. So we have the volume and we have the moles. So moles equal concentrations times the volume. Okay. So this will give us the moles of ethane dioic acid. Is it audible? My sound is clear. So we have the concentration, which is 0.5, and the volume. What about the volume of the solution? The volume of the solution is 500 cm cube. Which is 0.5 because we divided by 1000. So this will give us the moles of ethane dioic acid, which is CH3, like COOH bracket 2. So 0.025. Sorry, 0. Because it is 0.5 into 0.5, 0.25 is there. So we got the 0.25 moles. Now, first what we will do, this is the total mass of a, in the question they mentioned here, the total mass of a hydrated was 31.5 grams. Like this is the mass of the ethane dioic acid plus water was 31.5 gram, which is dissolved in 500 cm cube of the solution. So what we simply do, we'll find what, as we have the formula that we'll find the molar mass. How to find the molar mass? Look, you have moles equal mass in gram divided by the molar mass or the molecular mass. So you have the moles of, which is 0.25. How we got the same number of the moles? Because if you see, if I have a ethane dioic acid, I have like COOH in a bracket 2 dot XH2O. When it will break down into like ethane dioic acid plus X water molecule. So means what we did, using the concentration and the volume, we got the moles of ethane dioic acid, which were 0.25. And from moles of ethane dioic acid, the ratio is always the hydrated and anhydrous is always 1:1. So we'll get the same number of the moles of this compound, hydrated. So we got the moles of hydrated compound and we know the mass of hydrated compound. We'll find the molar mass of a hydrated compound. So mass in gram is 31.5 and the molar mass is unknown. So 31.5 divided by 0.25, that will give us 126. So 126 is a total mass. Now, what we do, because like total mass of this compound, COOH in a bracket 2 dot XH2O, that the total molecular mass of this compound is 126, which include carbon. And how many carbon are there? One carbon, like two carbon, and each is 12. It include oxygen, 16. And how many oxygen are there? Multiply by 4, because 2 multiplied by 2. And include hydrogen, 1 multiplied by 4. And it include water, X water, X is a mass of a water. So when we simplify this, 24 plus 4, 28, and 28 plus 64. So what is the total mass? This is 12, 64, 24, 90 is there, yeah. So this is 90 is equals to 126. 90 will move other side, 126 minus 90. So we will get 36. 36 gram of a water is there. It means how many moles divided by the molar mass of a water. Molar mass of a water is 18. So how many moles of water are there? 2. So means what is the value of X? Value of X is equals to 2. Is it clear? So first we got the moles of anhydrous salt. From moles of anhydrous salt, we got the moles of hydrated salt. From moles of hydrated salt and the mass of hydrated salt, we got the molar mass or a molecular mass. And from the molecular mass, we subtracted the mass of the ethane dioic acid. So we'll know how much water is there or what mass of a water. And then divided by the molar, we got the moles. Is it clear, this one? Any doubt? Any question or doubt here? Next we have is a question 4. This question is about the nitration. We can also find the mass of H2O by subtracting the total mass from that. Yes, you can do that method as well, but you need the actual mass of a hydrated salt first. Then only a subtraction can be done. Like you should know the moles of a water and then moles of a water. But this is a more common way in which we first find the total mass of a hydrated compound. We subtract the mass of anhydrous. We know the moles, like mass of a water. That's the most common method we use. This question is about the nitration of a methyl benzoate. So methyl benzoate nitration means like adding a nitro group. So first what we did, we weigh about 1.9 to 2.1 grams of a methyl benzoate in a 50 cm cube conical flask. Slowly add 5 cm cube of a concentrated sulfuric acid and swell the mixture and place the flask in an ice bath. Then 2 cm cube of a nitric acid is added and cool the nitric acid by immersing the test tube in an ice bath before slowly adding to a concentrated sulfuric acid. Allow this nitration mixture to cool. Use a teat pipette and a nitrated mixture. Use a teat pipette. Add a nitrating mixture very slowly into a conical flask, ensuring the temperature does not exceed 7. And allow the flask to stand at a room temperature about 15 minutes. Then pour a content into a beaker containing some crushed ice and impure methyl 3-benzoate will form. The recrystallize the methyl 3-benzoate using a methanol as a solvent and weigh the dry crystals and determine the melting point. A bottle of a concentrated nitric acid has 2 hazards warning. State the 2 hazards. Look, when a fire is there and letter O is there, what does it mean? It does not mean like flammable. You have to write it is oxidizing. Okay. Don't write flammable. They do accept it's flammable, but the best is oxidizing. And but in usually in the symbol, don't write flammable. Like oxidizing substance, yes, it can easily oxidize or can catch fire. And the second is a corrosive, when this symbol is for corrosive and this oxidizing. If it was a flammable specifically, then O will not be there. Then only the fire will be there, but not O. So this is oxidizing. Give a precaution to reduce the risk when using a concentrated nitric acid. Assume that the safety goggles and the lab coats are used. So if we want to minimize, because if we want to reduce the risk, what we should do, we are handling an acid, so acids are corrosive, so we should wear gloves. And this is a flammable substance as well, as you can see. So what else? We should keep it away from a flammable substance. Like it, flammable substance can catch fire near oxidizing agents. Explain why nitration mixture is added slowly in step 4. What was the step 4? Use a teat pipette, add a nitrating mixture and around 7 degrees. So what is the main reason? Because when mixing is there, the reaction is highly exothermic. So as a result, what will happen? Temperature of the reaction mixture might increase too much. And why we should like keep it 7 degree? Why not above 7? Because multiple nitration can happen. Like we only want only one nitro group. But what might happen if the temperature might be above 7 degree? Then multiple nitration can happen. Multiple nitration means like more nitro group can be attached to a benzene ring. We just want one of them to be attached. That's why we try to maintain a temperature low as possible. So one reason the reaction is exothermic, and due to a high exothermic reaction, multiple substitution might take place. So to avoid these multiple substitution, we keep the temperature below 7. And another thing you can also see, this is see ester is there. Ester can also decompose because C double bonded with O. So due to high temperature, hydrolysis of ester can also take place. So that's why to reduce that effect, like we don't want the compound to break down. That's why the temperature it's below 7. Another reason for that. During recrystallization, step 6, the methyl 3 nitrobenzene is dissolved in a minimum volume. If you remember the last when we discussed about organic synthesis, we always use a minimum volume of a hot solvent, and then you use a hot filtration and filter is cooled, resulting crystals and rinse. State why methanol is a suitable solvent for recrystallization of a methyl 3 nitrobenzene. So the suitability of the solvent depends on the type of the solvent, whether it is what kind of force it is having. So if you see the main purpose of selecting a solvent, so it's solubility. So methyl 3 nitrobenzene will be very soluble in methanol. Like it will have a higher solubility, and solubility, you always, like example, compare the why we prefer, because at high temperature it will dissolve more, at low temperature it will dissolve less. Like its solubility will change with temperature. Solubility does change with temperature. At low temperature, the substance is less soluble. At high temperature, substance is more soluble. So why we select this for a recrystallization? Because of its solubility, it change in solubility with temperature. That the 3-methyl 3 nitrobenzene will be more soluble at high temperature in methanol, and it will be less soluble at low temperature. Why we don't have to write about water here? Because they did not ask why water is not used. We just want to justify our answer with reference to the methanol. That the methanol is suitable because the 3 nitrobenzene solubility changes with temperature. At high temperature it is more soluble, and at low temperature it is less soluble. State the purpose of each filtration during a recrystallization. First, what we did a hot mixture was filtered, and then it is cooled, and then we filter. So there's one is a hot filtration, another one is a cold filtration. So what is the purpose of the first hot filtration? The first purpose of the hot filtration is remove the soluble impurities. Like because when it is hot, remove the insoluble impurities, I mean. Because when it is hot, when we add the 3-methyl, methyl 3-nitrobenzene, methyl 3-nitrobenzene and methanol, when it is added, so it will pass through the filter paper, and what is left on the filter paper is, why should we mention that low solubility? Because the solubility changes with temperature, and there should be a drastic. So what is the purpose of using the hot filtration? What is the purpose of adding a hot filtration? So that the insoluble substances left on the filter paper, and what passes through the filter paper is a filtrate. So main purpose of the hot filtration to remove the insoluble impurities.
Sir, can you please repeat the first part, because
Which
I
part?
wasn't hearing. Your voice was unheard. And
State why methanol is
CI.
suitable solvent. This one?
I asked you why should we
Yeah,
mention that
because the
there
temperature,
is low
look,
solubility,
the
low temperature?
solubility of a
Huh.
substance changes with the temperature. So for example, if there is no drastic change, let's say I have a substance at 20 degrees, like I have a methanol at 20, and the solubility is 2 grams per decimeter cube. When a temperature is high, let's say the same amount at 80 degrees, the solubility might be 2.1 gram per dm cube. So this is not a big change in the solubility. So this solvent will not be suitable. But a solvent which is having a greater change in the solubility as the temperature changes. So we have like example, let's say 2 grams per decimeter cube at 20 degrees. And when I increase the temperature, now it has a solubility of say 4 grams per dm cube. So when there's a greater difference in the solubility at different temperature, then this is the solvent which we prefer. The solvent which is having a greater difference in the solubility at different temperatures. Because this will, when we do recrystallization, very small amount will recrystallize. Like let's say I dissolve 2 grams in here in this. When I do, like, I was having 2 grams in this. So if I was having 2 grams was dissolved in this, or let's say 2.1 gram was dissolved in this. So when 2.1 gram is dissolved in this, when I do recrystallization, 2 gram will remain dissolved, and how much I will get? I will get 0.1 gram. So that's why when we do recrystallization, in this case, if there's a small difference in the solubility, small amount will recrystallize. But if there's a greater difference in the solubility, let's say this was 2.1 gram was dissolved, or a higher amount is dissolved. Like example, it is a 4 gram per dm cube. So let's say 3.5 gram was dissolved. When I do recrystallization, I cool down. So we'll get 2 grams. 2 gram will remain dissolved. So 2 gram will remain dissolved. How much solid will appear? 1.5 gram will appear. So when there is a greater difference in the solubility at different temperature, more solid will recrystallize as we change the temperature. So why methanol is a suitable? So why methanol is suitable? Because its solubility changes with temperature, and there's a greater change in the solubility. Clear?
Yeah. So like the significant change in solubility in high temperature will allow us to gain more mass when we
Right.
recrystallize.
Right.
Okay.
Then state the purpose of the each filtration during a recrystallization. So when we do recrystallization, when we obtain So when we obtain the, if what is the purpose of the hot filtration? Hot filtration, the substance will remain dissolved. So this will pass through a filtrate and the insoluble substances will left on the filter paper. So what is the purpose of the hot filtration? The hot filtration remove and separate the insoluble impurities. Okay. Then what is the purpose of the cold filtration? When we do cold filtration, like we filter it again. So the cold filtration, because the crystals will form now. So the crystals of the methyl 3 nitrobenzene will form here and the soluble impurities will passes through the filter paper. So the hot filtration remove the insoluble impurities, where cold filtration remove the soluble impurities. The soluble substances will remain dissolved and the crystals which we want, that will be crystallized and left on the filter paper. Is it clear? The difference between a hot and a cold filtration? Is it clear? Look, when we carry out a hot filtration means solution is hot. Okay. When the solution is hot, your when the solution is hot, so the substance 3 nitro 3 methyl 3 nitrobenzene, so the methyl 3 nitrobenzene will remain dissolved. And then what will happen to the insoluble substances? The insoluble substances will remain there. Okay. Now, when we carry out a filtration, the hot filtration, so when we are carrying out the hot filtration, what passes through is the soluble methyl 3 nitrobenzene. The soluble methyl 3 nitrobenzene will pass through, and what left on the filter paper is what? What is left on the filter paper? The insoluble substances. So what is the purpose of the soluble? What is the purpose of the hot filtration? When a filtrate is hot, the insoluble substances will be left on the filter paper and the soluble substances will pass through, which is including a methyl 3 nitrobenzene. Then when we do a cold filtration, when we carry out a cold filtration, what will happen? The insoluble the 3 methyl 3 nitrobenzene methyl 3 nitrobenzene crystals will form. So this is a solid, okay? And the other impurities, the substances, other impurities will remain dissolved. When we carry out a cold filtration, so on the filter paper, we are left with methyl 3 nitrobenzene, and what passes through a filter paper is a soluble impurities. So main purpose of the hot filtration is to remove insoluble impurities, and to remove the soluble impurities, we use a cold filtration. Is it clear? Is it clear now? Any doubt in this? Give the purpose of rinsing the crystals, stating why methanol is ice cold. So how we no the cold remove the soluble impurities, because the impurities will remain dissolved. When the filtrate, when the solution is cold, your crystals are formed. Your crystals are formed, and the impurities, if any other thing is there, that will remain soluble. So when you carry out a filtration, your crystals left on the filter paper and the solution which passes through, that will be the soluble impurities. Clear? So give the purpose of rinsing the crystal, like why we are rinsing a crystal or washing the crystal. The main purpose of washing a crystal is to remove any, like wash off any soluble impurities are there. Then we can also wash off and ice cold so that the crystals do not dissolve. Like again, what we did, as you can see, once we got the crystals, these are the crystals. We wash the crystals. When we wash the crystals, this solvent which we use a ice cold solvent, like very cold solvent. What is the purpose of ice cold solvent? Because first, why we wash with the solvent, so any impurities which are left, like the soluble impurities are left, that will be washed away. And why it is ice cold? So that it won't dissolve the crystals. Otherwise, if it was a hot solvent, again the crystals will dissolve. So we use a ice cold solvent to wash off the soluble impurities and soluble impurities, and so the crystals will not dissolve in the solvent. Is it clear? Is it clear, this one? 1.95 gram of a methyl benzoate reacted with an excess of a nitric acid to form 1.51 grams of a methyl 3 nitrobenzoate. The percentage yield. What is the percentage yield? Percentage yield is a practical value divided by theoretical value into 100. That is a percentage yield. So 1.95 gram with an excess form 1.51. Okay, that is the practical value. But theoretically, how much we should get? If you compare the mole is 1:1, as you can see the equation, the mole is 1:1. So if you take a mass ratio, 1.95 is methyl benzoate and 1.51 is methyl 3 nitrobenzoate. So that is a practical value. And according to this, the mass of a methyl benzoate is 136, and the mass of a methyl 3 nitrobenzoate is 181. So 136, according to the equation, 136 give 181. Then we have 1.95 gram. How much is there? X. Cross multiply. So when we cross multiply, we'll get the value for X. And this X is a theoretical value because 136 is 181. So 1.95 grams will give us X grams of this compound, which is 2.5952. So percentage yield is a practical value. The practical value is, according to the equation, we have 1.51, like according to the given question. Practically, how much nitrobenzene, methyl 3 nitrobenzene we get? We got 1.51 divided by the theoretical value, which is we should get 2.59 into 100. That will give us the yield, like percentage yield, like what proportion we get for this compound. Clear about this? Which is about 58%. It's showing 58%, so maybe 58%. Yeah. One possible reason for a less than 100% yield. So why we don't get the 100% yield? What might happen? The main thing is not like as we are doing recrystallization, maybe not all of the crystals, like not all the crystals formed during a recrystallization, like not all the methyl 3 nitrobenzene recrystallize, and some of the solution might be lost during a transfer from one filtration to another, or the reaction might not be complete. That these are different possible answers. Then a group of students carry out a series of experiments to investigate the kinetic of reaction between hydrogen peroxide and iodine in acidic condition. 10 cm cube of aqueous sodium thiosulfate in a conical flask. Added 5 cm cube of aqueous starch. This is then 5 cm cube of a potassium iodide solution. Measure 5 cm cube of hydrogen peroxide. Add hydrogen peroxide into a conical flask and mix thoroughly. And record the time for a solution to turn blue-black. Repeat the experiment. Vary the volume of aqueous potassium iodide and distill. Keep the total volume of a mixture constant. State the purpose of adding a thiosulfate in a step 1. Look, what is the main purpose of adding a thiosulfate? In this reaction, what is happening? When hydrogen peroxide is reacting with iodine forming iodine molecule, okay? So, and we add a thiosulfate so that this iodine molecule which is formed will react with a thiosulfate and convert back into iodine. Uh, because the color change will be visible, look, this is called iodine clock reaction. In iodine clock reaction, we have a mixture. A mixture is forming iodine molecule here. But because of the presence of the thiosulfate, as thiosulfate is present, so this iodine molecule will be removed. And in the solution already we have a starch, which is iodine in the presence of a starch give a blue-black color. So once iodine form, instantly it will react with thiosulfate. Then iodine form, react with thiosulfate. Iodine form, react with thiosulfate. Once all of the thiosulfate will be used up, then the iodine which is formed will not react with thiosulfate and starch will show a color change. So that is the main objective of the experiment. This is called an iodine clock reaction, in which first iodine which is formed will react with the thiosulfate. So we won't see a color change. But if a high concentration of a hydrogen peroxide is used, if we use more concentrated hydrogen peroxide, the color change, because we are investigating how the rate of a reaction is affected by the concentration of iodine and hydrogen peroxide or acid. So if we will change the concentration of each of the reagent and identify how much time it is taking for the appearance of the color, a blue-black color to appear. If a reaction is fast, then it will appear in a short time. If a reaction is slow, it will take longer time. So that is the main idea about this experiment. So state purpose of thiosulfate. The purpose of the thiosulfate is to react with iodine form so that instantly the color change won't be seen. It will take time. Once all of the thiosulfate is used up, then the color change will occur. So color change will only occur after a certain amount of a reaction has taken place. Is it clear? Then we have to plot a graph between 1 over t against the volume of a potassium iodide. You have to use this grid. Then deduce the order of a reaction. If you find if it is a straight line graph, a constant like volume is not affecting, it means it will be a zero order. Give a reason why concentration of potassium iodide solution is significantly lower than hydrogen peroxide and sulfuric acid. Because the main purpose of this experiment is we are investigating how the concentration of a hydrogen peroxide or sulfuric acid affect the rate, and the constant iodide it's a zero order. Give a reason why concentration. Yeah. So why concentration of a potassium iodide solution is significantly lower than hydrogen peroxide. So hydrogen peroxide and sulfuric acid are actually like excess of the reagent or too much, so that their concentration won't affect the rate. Because whenever we are investigating the factor affecting the rate, so the rate of the reaction only affected by the change in iodine concentration, and that's why we keep hydrogen peroxide and sulfuric acid in excess. Whenever we are investigating a rate, like example, a hydrogen peroxide is there, iodine is there, iodine is there, I mean, and acid. So if I'm investigating that the rate affected by iodide concentration, so what I have to do, I have to take excess of a hydrogen peroxide and excess of iodine. So I have to take these two in excess and iodine in a small quantity, so that if I change the iodine, the rate of reaction can be changed. I will investigate that. If we find a straight line graph, it means it will be a first order. If it's a horizontal line, means it is zero order. And if it is a curve, it will be a second order. Is it clear? Question 5. This was the last question for October 2023 paper.